And we are live. Hello everyone to today's Tech Excellence session. As you already probably know, our vision is to raise the bar of technical excellence across the world. And who are we? Well, everybody knows Valentina, of course. She's our founder and organizer of these sessions, and she's joined by Daniel, not today, but usually Alina and also me, who are also hosts and co-organizer of these sessions. We already had great speakers this year, and if you have missed any of them, well, you can find them on our YouTube channel and watch them again if you want to see it again. And we will continue to have great sessions also in the next couple of weeks and months to follow. As I said, if you want to follow us, Meetup, of course. If you're watching this, you already know that we are on Meetup. We're also on YouTube, and we are also active on LinkedIn, Twitter, and of course, we are programmers, so you can find some code also on GitHub. And we also have a growing community in our Discord channel. So if you want to discuss about software craftsmanship, test-driven development, clean architecture, or any of these topics, then join us in our Discord as well. Our sponsor is Optivem and partner is QE Unit. And now I'm very happy that we are joined by Wojciech Bulaty. Wojciech is CEO and product architect at Traffic Parrot. He has over 15 years of hands-on coding, testing, architecture, and leadership experience in various industries, and is an avid writer who has published peer-reviewed papers and articles on various websites like InfoQ, DZone, and many more. And at Traffic Parrot, he helps teams working with microservices to accelerate delivery, improve quality, and reduce time to market by providing a tool for API and system simulation. And today I'm very happy that his talk goes into exactly the same direction. So he will show us the 12 microservices testing techniques for dependency control. I'm very excited to hear about that. But before I hand over, I want to remind the audience that you are very much encouraged to write down any observation, comment, or question you have in the comment section down below, so we can pick them up afterwards when Wojciech has finished his talk and discuss them together in this group. But now, without further ado, Wojciech, it's up to you.
Okay, good stuff. Thanks a lot, Oliver. That was a really good introduction, you know. I mean, looks like I've done a few things, actually. I was like, you know, you've been doing this for so long that sometimes you're like, you know, now that you've actually mentioned it, I'm like, okay, there's been a few things I've done, actually. I guess it's good for everybody here today because hopefully what I talk about makes sense. So let's talk about these 12 microservices testing techniques for dependency control. So again, my name is Wojciech, and I've been doing software development for more than 15 years now. So like I said, hopefully whatever I cover here today makes sense. So first of all, what I wanted to cover is the difference between a monolith and a microservice. So all of us here are more or less on the same page. What is it that we mean when we say something is a monolith or something is a microservice? So we've got two rows here, a typical monolithic architecture and a typical microservices architecture, and four major differences. The first difference would be the team structure. So a typical monolithic architecture will be organized into separate teams of specialists, like UI developers, middleware developers, backend developers, operations, DBAs, etc. Then a typical microservices architecture would be organized around business capabilities. For example, you might have a team responsible for user onboarding, another team responsible for mobile number porting. And those teams would have a few developers, a couple of testers, a business person. They might have a part-time DBA and a part-time DevOps person. The next difference between monoliths and microservices are how things are supervised. So in monolithic architectures, what you'll find is that the governance is done centrally. So typically you might have architects that decide what technology stack you will be using, what tools, what frameworks, etc. for the whole product that the monolith implements. And then when it comes to microservices, the supervision is decentralized. So there's no central governance entity that will tell you how to do things typically. So you might have one team that's doing a 3-layered microservice architecture with Java, and another one that's running a Golang with spaghetti code, for example, right? It's not supervised. Then you've got data management. So typically a monolith would have a large database where all the data is stored. Whereas for microservices, you might have one database per microservice or a database for a number of microservices, but there will be more than one database and the data is decentralized. And typically for monolithic architectures, what you find is there's low to moderate levels of automation, and typically there would be automation around testing, test automation, if you want to call it that, and not too much automation in the on the infrastructure side. And then when it comes to microservices, you're going to have a lot of automation both on the testing side, but also on the infrastructure side. So things like infrastructure as code, for example. Okay, so now that we know more or less what does it mean when I say a monolith or a microservice, let's have a quick look how it could look like in test environments, for example. So we've got a monolith here that's a big application that's running or a dev and QA environment on a virtual machine or bare hardware connected to a database. And these typical three layers, right? UI, services, repositories, and adapters, and it's connecting to some backend or third-party mocks, simulators, or virtual services. And you might have another environment, the UAT environment, that's connected instead of to the mock simulators or virtual services, it will be connected to backend or real backend or third-party services. Okay, whereas a typical microservice architecture might look like this. So on your local environment or in CI/CD, you might have just one microservice that's connecting to a test container database and mock simulators of virtual services. You might have a shared test environment running on Docker, let's say in Kubernetes, and those microservices might be running on different tech stacks with different architectures, and might be connected to mock simulators, virtual services, and test container databases. And you also might have another environment where the real database or real third-party or backend services are used. So there's been a number of very good materials online created by different people covering the subject of testing microservices. And I would recommend having a look at Testing Strategies in a Microservice Architecture by Tommy Clemson. I really like and find a good trade of the idea how Spotify tests their microservices. So you Google for testing of microservices by Spotify. And I've also got a talk myself actually on YouTube, which is quite popular, on how software testers can test microservices. So we're not going to be covering how to test microservices, but what you'll need in those tests is to manage those dependencies of your microservices. And we'll cover that bit that will be useful in your development and testing. And the reason we're covering that is if you're moving from the world of monoliths to microservices, or you are already starting in the new world of microservices without a monolith, there's several new techniques available because of two things. First of all, you've got the world of containers available, so things like Docker. And that allows you to use several new techniques which we'll discuss shortly. And also on top of that, if you're doing microservices or creating microservices, what you have to keep in mind is that compared to a monolith, if you have a number of microservices, they will be using network connections to communicate with each other. So your testing architecture needs to adapt to those changes and be able to test those network connections. And we'll discuss that briefly as well, how these different dependency managing techniques will help you with that. So let's talk about using those dependencies in your microservice tests. We'll discuss 12 methods, and they're divided into 3 groups. The first group is using real dependencies in your tests. So things like, or I can use a test instance of another microservice when testing my microservice, etc., etc. The second group of methods that we'll cover are test doubles, so things like mocks, simulators, emulators, in-memory databases, etc. And the third group that I called helper techniques will be also sometimes useful, which is things like test containers and legacy in a box. So let's start off with discussing these real dependencies and using real dependencies in your tests of your microservices. We'll be comparing all of these 12 techniques on these dimensions. So first of all, what we look at is what is the impact of the maturity of your team on adopting a given approach. For example, let's say you're a new team with junior developers and a couple of mid-level developers with 1 or 2 years of experience. That might impact which techniques are available to you or will make sense to be adopted by your team, as opposed to, for example, let's say you've got a team of several mid-level developers with senior developers with an average experience age of 7 to 10 years. Then the number of techniques that you can use changes a bit. And the other 3 dimensions that we'll be discussing for each of these techniques is how the given technique impacts your time to market, costs, and risks of your project. So quite high-level high-level metrics on how we can use these techniques. And what I also wanted to notice here before we start is that typically on a given project, you'll be using a combination of these techniques, not just one of these techniques. And that typically depends on the number of microservices that you have in your stack and the types of dependencies that you have. So let's start with the first one. So the first technique is using a real dependency in testing your microservice, and it is connecting your microservice to a test instance of another microservice. Well, it doesn't get simpler than that. You've got a microservice running on your laptop, or let's say in your CI/CD pipeline or in your Kubernetes environment, and you are connecting it to another test instance of another microservice, either locally on Kubernetes, etc. Right? Doesn't get simpler than that. So what are the consequences of using this approach? First of all, the impact of the maturity of your team is quite low on choosing this approach or adopting this approach. Like I said a couple of times already, it doesn't get simpler than that. You can connect one microservice to another test instance of a microservice. It's fairly straightforward to start with. So it's going to be quick to start with. The cost of implementing this is quite low and the complexity is low. So when you have not too many microservices, it's quite easy to do actually. And the benefit you get here with testing against real dependencies, not test doubles, which we'll discuss soon, is that this technique reduces the chances of introducing issues in your test doubles. And from my experience, this is probably one of the more popular techniques to start with when companies start fresh with microservices. But you have to keep in mind that, and that's from my experience as well with working with different clients across different industries, this can very much slow projects down as the complexity grows and you add on microservices or complexities to your services. And what this ties down to is the risk of eventually not implementing the optimal test architecture for a given stack of, let's say, microservices. So one sensible decision at a time, you could be adding one more test instance of another microservice to your suite of tests. Eventually, you end up with a number of microservices that are untestable actually in that way. So I'm actually thinking about the client we're working with right now, where they've got 40 microservices running in a Kubernetes cluster, and they actually want to go back and start introducing test doubles because testing those 40 microservices at the same time in a Kubernetes cluster is not manageable for them. So they're actually thinking about, well, we need to go back. We used to be able to develop and test our microservices individually. At some point, it made sense to test them in Kubernetes as a whole, but right now we want to go back and start again introducing test doubles and testing and developing them locally. So again, a good technique to start with. Just got to keep in mind that I've seen a lot of teams that shoot themselves in the foot when they don't pay attention and don't evolve their testing architecture as the complexity of their microservice architecture grows. Okay, so the second technique, you can test your microservice with a production instance of another microservice. So quite a bit similar to what we've done right now, but right now we're connecting your microservice to a production instance of another microservice. Well, that's going to pose some risks, right? So the maturity of your team will have an impact, moderate impact on choosing this approach, primarily because if you connect your test microservice to a production instance of another microservice, you might change the state of the production microservice, right? And I've actually seen that happen for a client that were testing a microservice in a CI/CD pipeline that was configured to connect to a production microservice. And at some point, it started changing this test data. It wasn't just read-only, and somebody just forgot about it, and the production services were being changed, right? So you got to keep in mind, this is a risky endeavor. Sometimes it might make sense, but there's significant risk. The second risk is, if you think about it, your test can actually bring down the production services, saturate connection pools. If you run load tests, they can increase the load on the production servers and bring them down, etc. Sometimes this might make sense. Let's say you've got a microservice that provides the current list of countries, which is just read-only, or like a address lookup service is just read-only. It might make sense temporarily to do it if you gotta have something working in a day or something like that, right? And you don't have time to set up, I don't know, a proper testing architecture, mocks or whatnot on that day, okay? All right, so the third technique of testing microservices and with real dependencies is you can test your microservice with third-party dependencies. So your microservice depends on third-party services, and you can test your microservice running locally in Kubernetes CI/CD with by connecting it to those third-party dependencies. A bit similar to connecting a microservice to a production system. If the third-party environment is a production system, actually, you're again running the risk of changing those production systems on the third-party side, right? So quite a significant risk. You also have to keep in mind that as with all these methods where we're testing a microservice with a real dependency, not a test double, you're always running into this risk of slowing down and getting more costly as the complexity grows, right? So the more microservices you add, all of these techniques are going to be, might start slowing you down further down the line and might get costly to maintain. Specifically with this one, you also might want to keep in mind that calls to third-party APIs can generate costs. So for example, let's say you're running small performance test and you're running, let's say, 1,000 transactions per second, and every 1,000 transactions costs you $1, right? So then your performance test of your microservice that's actually connecting to a real third-party dependency will cost you $1 a second, which is $60 a minute, right? So let's say you run a 10-minute performance test, that's what, $600? That might not be much for you, for your team, I don't know, right? But it's something to keep in mind that these third-party calls are often charged per number of invocations. And some other issues, again, which is typical for using real dependencies. It might be hard to set up hypothetical or area scenarios. So these third-party systems, especially the older ones, will have issues with setting up very specific, intricate hypothetical scenarios that you actually want to test, but it's not possible to set them up on that API. So we'll cover how you can do that with other techniques soon, but it's worth keeping in mind that if you're connecting your microservice with a test of production environment with third-party dependency, these are the issues you might hit. Then you can also test your microservice with another real dependency, and it's a legacy non-microservice system. For example, You might be working in a big financial institution and you've got a mainframe that's been there for 30 years. Or you might have an old Java application that's been running for 20 years and the department's moving away from that, but you still have to interface with it. So this is what we're talking about here. So again, the typical, when you're testing a microservice with a real dependency, you got the same wins again. So it's quick to start with. You just connect it to that service. It's low cost to start with when you've just got one microservice and one dependency, for example. And again, if you're using real dependencies in your test, you don't have the issue of test doubles, having issues like getting out of date, etc. What I found with our clients is that there's a few significant risks, especially for large financial companies. There is setting up test data in these mainframes or legacy systems can be quite time consuming and costly. For example, I've worked with a UK bank, and if you wanted to get test data of a certain type in your test environment on the monolithic system that we were interfacing with, you had to wait 3 months and be very specific about what type of test data you want. And then you had to actually pay from internal budgets the test data setup team to set it up for you. So it wasn't only 3 months you had to wait, you also had to pay for it, right? And imagine you want to move fast in this kind of environment. Yeah, and you also got to keep in mind that if you wanted to provision a new environment of that mainframe, let's say, or that legacy monolithic system, it might be time consuming to set up a new instance of that. So another example from this UK bank that I was working with, if you wanted to set up a new environment just for the purpose of our team's testing so we can fiddle with the test data ourselves, etc., it was like $150,000 per year, and you had to wait 6 to 12 months to be able to get it at all, right? Like access to that environment. So you have to wait 6 to 12 months to get the environment, and it's going to cost you 150 grand, right? 150 grand for some teams might be okay, right? It is a lot to me. For some, banking teams, it might be not too much, but waiting for 6 to 12 months might be actually problematic. So just keep in mind, there's pros and cons to this technique like any other, and it makes sense in certain conditions, but you're running certain risks here as well, especially in these financial institutions. And another technique of testing your microservice with a real dependency of another type is testing a microservice with hardware dependencies. So for example, you've got a microservice that connects to a hardware device, and you want to make sure that they work well together. So the big, from my experience working with different clients, the big advantage of using this technique is that these hardware devices, typically when they're a bit older, and there's a lot of these old devices across different industries, they have quite unintuitive services or APIs, and it's not clear how to use them. But what you get when you use this technique and you connect your microservice to that real hardware dependency is you get very fast feedback on how does that API or service actually work, given the documentation is incomplete, or you don't know, you can't actually understand after reading the documentation how certain conditions would be implemented. Okay, so that's a very good, this is how I've seen the clients I was working with succeed with this method. What you got to keep in mind is that if you wanted, those hardware dependencies are usually limited. So you're going to have one, for example, per department for available for testing. So let's say you've got a couple of teams that want to test on the same device. Suddenly they're sharing the same hardware device, and you want them to be parallelized, let's say. So you think, okay, I'm just going to order another one of these so that my team can work in parallel to the other team and not step on each other's toes when they're connecting to this hardware device and changing their state, etc. So from my practice, it might be quite time consuming to order these devices, and they can be quite costly. So again, I was working with this client, a UK media company, and they had this device that was used by a team and to integrate with, but there were a couple of other teams that wanted to have access to the device as well. And what happened was when the order was trying to be, the management tried to place an order for another type of these, another instance of these devices. The timeline came back as 6 months, right? So again, you're gonna have to wait 6 months to get an instance of this hardware dependency. So sometimes you're running this risk of, well, maybe this technique is okay, but I might have to think about, in the case I can't order it, about another technique. And again, as with other techniques, when you're using real dependencies in the test of your microservices, this might slow you down as the complexity grows, and you're running this general risk of not implementing the optimal testing architecture of your microservices if you're just using real dependencies in your test. Okay, so we've covered how we can use real dependencies when testing our microservices. That was the first group. The second group of methods we can use is using test doubles. What is a test double? A test double is a thing that acts like the actual system, but it's easier to use. It's less complicated for the purpose of testing your microservice. But in return, it allows you to build a scalable architecture of these microservices. And we're going to talk about a number of these techniques right now. But you might be asking yourself, well, why would I use these test doubles in the first place, right? Why not just use these real dependencies? And there's a number of problems developers and testers would see on day-to-day basis that these test doubles would solve. For example, the first typical problem is an API or service is not yet available. Let's say there's two teams working in parallel on a product, and the other team that your team is depending on will be ready in 2 or 3 months. So that service is not yet available. So you actually can't connect your microservice to another instance, be it test or production microservice, because that's not ready yet. So how test doubles come in handy in this scenario is that you can use a test double to pretend to be that real API or service and simulate it while it's not available. Another problem developers and testers would see is that manual processes in backends or third-party systems prevent your development and testing efforts. I've got an example here in mind where we've been working with a client where they were integrating with a government service, and whenever you send a request over IBM MQ to that government service, it would take 30 minutes to 2 days to get a response back, because there was some agent on their side that had to do something manually for that response to come back. So imagine trying to do any type of development in that environment, or any type of automated testing, having to wait for a response for 30 minutes to 2 days. What you can do in this case is use a test double, which will automate those manual processes in the backend or third-party systems. And this company in particular, they've used a tool that would simulate those responses and essentially respond in milliseconds with a very specific response they've configured it to, instead of hours or days. Another problem you might think about that you see on day-to-day basis that might be solved by test doubles is test data setup of refreshers required. So this is typical for a bit older systems where, like I said, for example, financial institutions, where you have to talk to a separate team where they need to refresh the database in a legacy system so you can test your microservices against those services, or they need to set up new types of test data that's not in an environment yet. So test doubles help you here because they're under your control. So you can put anything you want in those test doubles and have those have the test data set up or automated refreshes just because they're under your control. Another problem that as a developer tester you see on day-to-day basis is that you might have low test coverage because it might be difficult to set up hypothetical or error scenarios in those dependent systems. And how test doubles help you here is they help you by simulating those error or hypothetical scenarios. Again, you do it yourself in those test doubles just because you can configure them to return any type of response you would like. Another typical issue is that third-party APIs or services have restrictions like, for example, a test environment for a third party might have different rate limits to the production service. And this doesn't allow you to do as much automated testing as you'd like in your CI/CD pipeline, for example. So what you can do is use a test double to simulate that service or API and have as many responses as you'd like. What's also important to notice with microservices that communicate with multiple different types of dependencies, let's say we've got a microservice that communicates to a hardware device, two other microservices, a mainframe, and a legacy monolithic application. And you might have issues in production that are hard to replicate in your test environment or locally because those dependent systems have to be in very specific states with very specific test data to be able to trigger your microservice to be in a scenario where that issue manifests itself. So test doubles come in handy here because you can configure each of those dependencies test doubles to replicate that hard to replicate scenario quite easily because you're just working with requests and responses instead of the state of the whole mainframe or the state of the whole third-party system, etc. And there's also issues like intermittent failure with third-party APIs. I've got an actually recent example here from a third-party API it's a shipping API. It's quite widely used across the world. And if you're sending a tracking request for a given identifier, parcel identifier, depending on the time of the day, the moon phases, etc., it will return different responses. So imagine your tests actually depend on the response from the third party to make some informed decisions about the assertions of what you put on your microservice. Well, it's impossible, right? What you can do is stabilize those responses from the third party, and instead of returning different responses for the same request, you can tell it to return, tell the test double to return the same response for a given request, and that way your tests and your development efforts locally in CI/CD, etc., become more stable because the issues you see then are not because of the intermittent failures on the third-party side or the backend side. They're only because when something breaks, you know it's your test or your production code. Okay, so we've covered a number of issues you might see during your day-to-day activities as a developer or tester, and how test doubles can help you solve them. So let's discuss the types of test doubles that you typically see in these microservice architectures or microservice testing architectures. And the first group is called stubs. What is a stub? Well, a stub is a test double, so a thing that replicates the behavior of your dependency for the purpose of your test. And typically stubs, when you say the word stub, it means that it has been built by you or your team or by somebody in your company. And yeah, so what's the consequence of using this approach? Well, first of all, you got to keep in mind that somebody had to create the stub. So there might be some time needed to, you need to invest to get started with this approach. Somebody has to create the stub or have had to create it for you to be able to use it. And it will typically require some in-house development and coding skills, and might need some additional effort if you wanted to make it available to your QA team, not just development team. As is, let's say you need to be a standalone runner, it needs to have a user interface to be able to configure the responses that the stub is going to return. But what you get in return for this investment, this moderate amount of investment, is good benefits, which is it will reduce your time to market significantly with this moderate time investment, and it can reduce your costs significantly. It will allow you to test more scenarios for your microservice by simulating those error or hypothetical situations. And since these stubs are running typically in process, so let's say you'd have a stub that's stubbing out a Java method or a C# class, etc. What that means, you've got high granularity or high resolution of control over what gets returned to your microservice. One important problem with stubs is the minute you write them, you got to keep in mind it's a snapshot of what the real dependency was doing right now. So if the real dependency starts evolving, for example, you're creating a stub for another microservice that's changing frequently, it can become out of date. So you gotta have to have a strategy on how to keep these stubs up to date. Sometimes it might not be needed just because the services that you stub are very stable. For example, all third-party APIs that have been around on the market for a long time, they're typically quite stable and nothing changes on their side. So creating a stub there and capturing that behavior in your stub might mean that the stub's going to be good for a while. The second technique of using test doubles, also the second group of techniques, is called mocks. What are mocks? Mocks, when somebody says mocks, they typically mean something like a stub, but it allows you to do one more thing, which is verification of the request you've sent to it. So if I'm using a mock in my tests, I can verify both the request that's been sent to the mock as well as the response that I get back from the mock. So this allows me to test both sides of the contract, let's say, between those two dependencies, my microservice or the third party, my microservice or another microservice, etc. And typically, these mocks are actually created using open source libraries. And this is a very widely used approach. It can help you reduce the time to market significantly and the cost significantly, especially if you use the open source tools. They can shorten the time to market and help you lower the cost even more. And as with any test double, it increases the test coverage by helping you simulate those error scenarios or hypothetical scenarios. Mocks specifically allow you to verify the request that's been made to the dependency. And again, as with stubs, if you're running your mocks in process, you can mock very small bits of, let's say, code or behavior or functionality, which means you get high resolution of mocking, which means you can put your system in very intricate states to simulate those error or hypothetical situations. The big risk, again, you're running here is the minute you write your mocks, they become out of date potentially, right? Because the real dependency might change. And sometimes the real dependency changes, sometimes it does not. If you're running, if, for example, you're working as part of a startup that's creating several microservices and the boundaries between those microservices are not yet very well defined, creating mocks for those APIs might be problematic because those APIs might be getting out of date quite quickly, actually. Whereas if you create a mock for an API that's been stable for many years, you should be safe there. Yeah, and one more thing you got to keep in mind is that mocks are created by developers, typically the open source ones. They're created by developers for developers, so they typically would require coding skills. So if you're a QA and you want to use mocks, open source tools, you got to keep in mind that typically, not all of them, but typically they will require coding skills, some level of coding skills. Okay, so the next method of using test doubles when testing your microservices is called API and system simulation. also by some vendors called service virtualization, and by others API mocking. And what is that? Well, it's a test double that works over the wire. So what that means is you wouldn't be mocking necessarily specific functions in your code or classes or methods, etc. What you would be simulating is network traffic. So let's say your microservice communicates over HTTP or gRPC or JMS IBM with different systems. What you would simulate is the protocol responses. So a HTTP request, HTTP response, gRPC protobuf request, gRPC protobuf response, and JMS IBM request, JMS IBM response, in this case, over the wire. So what are the consequences of using this approach? It's one of the fastest to use, especially if you use off-the-shelf products and sorry, just one more thing. Typically, these API and system simulator tools, they're off the shelf, either open source or commercial, just because they have a bunch of features that allow you to get up to speed quite quickly. So, like I said, if you use those off-the-shelf products, they'll help you to get started quite quickly, either open source or commercial. And most of these tools will support different ways of getting started fast, like recording and replaying the traffic to create those system simulators, API mocks, or virtual services, or generating them from specs like OpenAPI, Swagger, Protobuf, etc. Those products can be quite cost effective of open source and commercial, but what you got to keep in mind that some of those commercial products have been on the market for quite some time, and they can get quite expensive. And expensive means different thing to different companies, but let's say some of these tools might actually start at, let's say, $200,000 per year, right? So for you, it might not be expensive. For somebody else, it might be expensive. And what you got to keep in mind is, since they're running in a separate process, you got to have space for that separate process, right? So some of these tools might actually be consuming 100 megabytes of memory and 100 megabytes of disk, which seems fine, right, in the world of containers. But some of these commercial tools, especially commercial, not the open source, but some of the commercial ones would consume gigabytes of disk space and gigabytes of memory to start with, without even creating any API system simulation or service virtualization. So just keep in mind that's a risk you're running here. You got to check that out when you use one of these tools. What you get in this case is, apart from getting fast to a solution, which is having a test double in place, these tools, typically both open source and especially commercial, they'll come with a lot of documentation, and they will help you reduce risk of making common mistakes because there's typically a lot of documentation for those tools. They'll also allow you to simulate network issues on the actual network level, which is quite important for especially large microservice stacks, because I've actually got an example in mind of one client we are working with, where a connection between two microservices in a stack of around 120 microservices actually almost brought down the whole stack of microservices, because it saturated one pool of threads here, which populated and populated across the whole stack eventually. So simulating these network issues might be a good idea for larger stacks of microservices. Again, as with any test doubles, you're able to simulate error and hypothetical situations. And typically these API and system simulators are support both QAs and development teams. So I've got an example here in mind where one of the clients we were working with used the same, there was a team of developers that were creating these API simulators in a tool, and running their tests locally using Maven, Java, etc., and then running them in CI/CD. And some of those API simulators were actually then used by the testers, the very same simulators, by testers on their team to do manual exploratory testing. So effective use of work there, right? Reusing the artifacts. So, and the important thing here is that we've noticed that the problem with test doubles is they can become obsolete or out of date if the real system changes. So you got to keep in mind that when you're choosing this tool and you've got a situation where the real system can change, go for a tool that supports keeping those simulators up to date. And there's tools like that. Another type of test doubles is emulators. What is an emulator? Let me give you an example. So an emulator is a thing that replicates very closely the behavior of a real system. And you'll typically see it, for example, in the hardware space, where you've got a hardware device that's quite hard to provision and expensive for your test environments. But what you get along with that, when you purchase a number of these devices, you get a software emulator that you can use in your tests locally, CI/CD on your test environments. Okay, so there's big advantages to using these emulators in your testing infrastructure. Typically, they're quite easy and fast to start with and can be quite cost effective if you use the off-the-shelf emulators. So you just get a ready one for your device or for your service. And they typically will allow you to actually test the hypothetical situations to increase your test coverage, and typically they would support both QA and development teams. Just keep in mind that when you're working with emulators and you're actually creating them in-house, so you're developing an emulator for a device or for a service, it can take some time to develop and can be quite costly. And if you're creating them yourself, those emulators, you might introduce discrepancies between the emulator and the real service. So just keep that in mind. The last test double, in-memory databases. So what is an in-memory database? Let's say you're using an Oracle or DB2 database that's running somewhere, DB2 on a mainframe, for example, and you're creating your microservice, and your microservice needs to connect to the DB2 database for whatever reason, right? What you can do is actually locally run an in-memory database, open source or commercial, and tell the database, hey, behave like an Oracle or behave like a DB2 database for the purpose of my testing. And that's what an in-memory database is. So it solves a couple of big problems here, especially in, let's say, large financial institutions where you've got these mainframes, for example, and you got to connect to a database, and you need some more space on that mainframe database, and that might be problematic and costly. So you just can run those tests maybe only once in a while, but on your local development machines or in your CI/CD pipelines, you might be able to just get away with testing most of the use cases using an in-memory database. Just one thing to keep in mind is that those in-memory databases, although they these days represent those real databases quite closely, they still have some discrepancies between how the real database works and how this in-memory database works. So it's still worth testing with that real database once in a while. And lastly, we've got those two helper techniques that will help you manage some of the complexity around using these other techniques. The first one is test containers. What is a test container? So we're living in this new world of containers where you can run, let's say, Docker containers anywhere you like. And what followed with this trend was that vendors, for example, like IBM or Oracle, allow you to run development versions of their product, like development version of the Oracle database or developer IBM MQ for developers, the broker, inside a container that's ready-made for you, and you can just pull it in locally and run a test container of a database of any other type of dependency you want, really, locally or in your CI/CD system, or even in your Kubernetes test environment. So what are the advantages of using this approach? Well, since you're not reliant on other teams like the Oracle team or the mainframe team, it allows your team to move at your own pace, and it can reduce the cost of having to pay for these commercial tools if you can use the development versions in test containers locally. You can also remember, test containers is about running anything in a container. So it could be even an open source database, the point, or another microservice. The point is you're running a container with a dependency locally that's pre-configured by somebody for you. What you got to keep in mind, though, is there's a slight risk that those test containers might be configured differently to the real dependency. So you got to test with the real dependency once in a while as well. And last but not least, legacy in a box. So what this means is you're taking your legacy system and putting it in a container so you can run it locally or in CI/CD or anywhere you like. But the point is, it's not running in the shared environment on WebLogic with an Oracle database on a mainframe, etc. What you're doing is putting it in a container, running it without the Oracle database, just with an in-memory database. You're refactoring it to, instead of running on a WebLogic WebLogic application container, you're running it on, let's say, a open source Jetty, embedded Jetty instance. So after you've done some of this work, you're able to run your legacy system that's almost fully functional, but good enough for the purpose of your testing of your microservices in a container, and you can run it anywhere, locally, CI/CD, etc. So this technique might require some seniority on your team, just because you might need some refactoring of this legacy dependency to be able to route without any dependencies, external dependencies of that system inside that container. But what this gives you is typically in these big institutions, financial institutions, etc., it's much easier to work with this type of method or legacy in a box than integrating with those real environments where those real systems are running. And again, like as with this is using a real dependency actually in your test suite, right? So it's a narrowed down or a cut up version of simplified version of a real legacy that's running in a container. So you're still running the risk of not implementing the optimal test architecture. Just keep in mind that's a risk you're running here. Okay, so we've covered these 12 methods. The point I'm trying to make here again is each method has its place, and typically you'll be using a number of these methods as the complexity of your microservices architecture grows. So I've been talking for like 50 minutes here now, and right now we don't have much time to talk about the details of how you would apply these methods. But what I would encourage you is to have a look at an article that we've published in 2019 that covers actually 6 case studies of companies and shows you a combination of different techniques each of these companies used. And you've got a case study of a team there or a department there that was using TDD, BDD, consumer-driven contract testing, the latest stuff. But you've also got a case study of a company that was moving to automated testing for the first time, right? So a broad spectrum of the market case studies. Please have a look at that in your free time if you feel like it. And one important thing to mention here is that those microservices, they're communicating with each other and other dependencies, which means there's implicit contracts between those dependencies and other microservices. So there's going to be different techniques I'd like you to keep in mind when managing those contracts. And I'll only list them here so you know they exist. We're not going to cover pros and cons because we're running out of time. But the point I'm making here is there's a few techniques. Just keep in mind they exist, and you'll have them in your toolbox to pull out and remember, oh yeah, this technique existed. I can go and Google how to use it. Okay. So the first one is contract snapshot test. What is this? Let's say you're using a mock and you've created a mock for a third-party dependency. You've actually created a snapshot of a contract between your dependency and the third-party dependency. So you've got essentially a contract snapshot test, one way of managing the contracts. The second one is the second technique to managing these contracts is contract snapshot refreshes. So you can refresh that snapshot that you've done. And some of the tools, some of the test double tools like API and system simulation tools, for example, will allow you to do that. So you can re-record the You can re-record the traffic between you and your dependency, or you can regenerate it, etc., depending on the tool. The third technique for managing contracts I'd like you to be aware of is consumer-driven contract testing. What is that? Well, it comes from the world of consumer-driven contracts. So it's a technique where it's not your producers that define the contract that your consumers will use. It's the consumers that work very closely with the producer to define the contract of the service. And what follows is consumer-driven contract testing, and a technique to use in this type of environment of making sure the contracts are met. Very powerful technique. It comes with trade-off when you start scaling it. I would encourage you to have a look at it as well. Another technique for managing these contracts is narrow integration testing. For example, you're testing one microservice with another test instance or a production instance of another microservice. You're actually testing the contract narrowly just between those two microservices implicitly, right? So this is per contract narrow integration testing. And another type of per contract narrow integration testing is actually writing API tests for a given API. So your APIs capture how the contract looks like, but just this one API. So again, narrow integration tests, not across the whole stack, just narrow between two microservices. And another technique I'd like you to keep in mind is when you're running in these microservice architectures, one of the benefits teams strive for, and the reason they move from monoliths to microservices, and some teams shouldn't actually move from monoliths to microservices if they don't want these microservice benefits. And one of these benefits is that you can release your microservices independently of other teams. So what that means is that your microservice should be compatible with the previous version or the current version of the microservice that's running in production. And it should be compatible with the test version, which is the next version of the other dependent microservice that's running in production. So you have to test the combinations of the latest and production artifacts so that you can release independently those microservices. And the last infamous method of testing contracts is end-to-end testing. So you're testing your whole stack of microservices and your whole product across all end-to-end user journeys. And what happens if you run a test like that across your whole stack is you're inherently or indirectly testing the contracts between different microservices, right? So end-to-end testing is actually a means of testing contracts between your microservices and your third-party dependencies, etc. What you got to keep in mind, there's a lot of good stuff you can do with end-to-end testing, but there's a lot more bad you can do with it. And there's been a bunch of articles written about how why to avoid end-to-end testing. All I'm saying is have it in your list as a technique that you know exists, and Google or read about or see YouTube videos about the pros and cons of this technique. There's going to be more cons than pros in the world of microservices, but it's there for you. The sixth technique of managing contracts in this complex world of distributed microservices with different dependencies. So I've been talking for an hour, and I imagine you might be a bit overwhelmed, right? But I wanted to get this list of techniques you should be able to use at some point, either today or at some point in the future. And I want to make this point that it's actually quite easy to start with. Think about those problems we discussed that test doubles, for example, can solve for you. And you can think about, well, which is the one that bites me the most and is most problematic for me today. That can be one microservice, just one API, or one team. You don't have to, suddenly change your whole organization. You can just start very small. One microservice, one API, and one team. So again, even though I've been talking here for a while, trust me, it's quite easy to get started. Pick the most painful problem that you've seen on the list that we've discussed of problems that this can help you with, and go with that. You don't have to do everything at the same time. So yeah, thank you so much for listening to me here today. I hope what you get out of today is the list of techniques you're able to use for testing microservices, and it's going to be in your pocket so you can remember about those techniques, and when the time comes, you'll be able to at least remember that a technique like that exists. It might be applicable in my case, and you'll be able to go further research how to apply it in your specific use case. If you like this type of content, please feel free to follow me on LinkedIn. There's a link to my LinkedIn. And if you've got any questions, you'd like to reach out to me, please feel free to contact me at wojciech@trafficparrot.com. And again, I work for Traffic Parrot, and we're actually a company that has got the tool called Traffic Parrot, and we provide an API and system simulator, which is technique number 8. So if you need technique number 8 and you'd like to learn more and you're happy using commercial offerings, not just open source, feel free to reach out to me. Thank you so much. And I think I'll pass on to Oli and the rest of organizers to continue with the questions, I think.
Thank you, Wojciech. Wow. Now we have a list of things we can actually do to test our microservices and maybe not fail. So well, let's start with probably the most important thing, which is the tools. So nice, love testing tools. This is what Maximiano writes. And we can also probably jump right into the next question, like what are common tools used for API and system simulators? And I assume it's yours. Or you can...
Yes, so across our customer base, the most common one is our tool, right? But yes, so let me actually share my screen for a second. That's a very good question. And I'm going to bring up. Is it okay if I share another tab? Is that okay?
If it works, yes.
I'll stop sharing right now. And I'll start sharing again. I think you might need to add it. Are you able to see a comparison of API simulation tools?
I can.
Awesome. So if you go to this page on Wikipedia, comparison of API simulation tools, there's a number of tools here. One of them is ours, but you'll be able to compare them looking at whether they're free open source, whether they're free, what APIs or protocols they support, whether they're scriptable, programmable, have a GUI, they support Docker or cloud, right? And there's a number of tools here for different protocols, etc. There's a lot of open source tools, and there's a bunch of commercial ones as well. Just because I say, I'm one of the, I represent one of these companies, I'm going to, let's say, skip talking about our competitors here. But if I was on your side, right, because I guess that's the question, what I would do personally is check out this website and see if any of these open source tools is good enough for you. If open source is good enough for you and you typically use open source tools in your stack, that's probably the right way to go. You don't want to start introducing commercial tools unless there's a good reason, and there are some good reasons, for example, missing protocols or missing features in the open source tool. Then you might think about, okay, maybe it's time to start introducing commercial tools. And yeah, that's how I would go about it if I was on the other side, right? And obviously, since I represent one of these vendors, I'm always happy to answer any questions. Just feel free to drop me an email or reach out to me via LinkedIn, and I'll be more than happy to help. It doesn't have to be, you don't have to purchase from us. I'm happy to help, regardless, direct you in the right direction if you share your specifics of your use case. Did that answer your question, Oliver, I think? I don't know. That was tech excellence. Okay.
Yeah, I have a follow-up also there from the open source options, since I think quite often people start with open source first before they consider anything else. Which of these are most popular? Like, what are the top 1, 2, 3 in the open source space?
Good question, Valentina. So, popular might mean different things for different segments of the market. I'm going to assume we're talking about the general public, and that means that they're probably using just HTTP. Then you're using IBM, MQ, or gRPC on any of the other protocols, just because HTTP is the most popular protocol across the web and different companies. So let's focus on HTTP only and open source. when we work with companies, what we see internally they use, along with our tools sometimes even, is open source tools like Mountebank and open source WireMock. So for example, they would use those two tools, either Mountebank or WireMock for doing HTTP, and that would come to us for other protocols. So from my point of view, and if you look at the stars on GitHub on those projects, you could take that as the number of stars on GitHub projects as a proxy for how popular a given project is. And you could look at also the number of contributors. So it's from, so, you know, you got my perspective. What do our clients actually use along with our tool? But you can also look at, let's say, just the raw data itself on GitHub, for example. From my experience for HTTP, if we're just talking about HTTP, the two tools will be Mountebank and WireMock. And then if you go to other protocols, there's going to be other tools, but that's going to be a bit more niche.
Mm-hmm.
Does that answer your question?
Yep, that was a good summary, so that at least the audience has an idea of where they could get, you know, how to get started. So thanks for that.
Awesome.
And we will also continue with that because it's also interesting if you're a backend developer. So are there any libraries that backend developers would need to use? So what's the role of the developers in simulation testing?
Yes, that's a good question. So you got to keep in mind that the simulation, if you use the wording that I've used in this presentation, is just technique number 8, right? And you've got several types of test doubles you could use. And what I found with our clients is that backend developers would, for example, in the Java stack, they could use mocks that are Mockito mocks, and the name of the tool is Mockito. So those are in-process mocks that you would be using for creating mocks of classes, methods, interfaces inside your code, but those are in process, so they don't go over the wire. So this is technique number, I think, 7, not 8. If you wanted to go over the wire, again, if you're just looking for open source, WireMock and Mountebank would do for you. But this is a very good question and goes back to how does your testing architecture look like, and how do you split up the complexity of the components you like to test? And one of the things that I've seen work well in general, let's say, without going to the corner cases, is the Spotify model of testing of microservices, which means you're going to have a number of tests that integrate with other services. Can I actually share my screen for a second?
Mm-hmm.
Spotify services testing. Okay. Present. You should be able to see like a honeycomb of microservices testing.
Yep.
So there's different ways you can structure the testing infrastructure of your individual microservice or your stack of microservices. That typically follows how your actual microservice architecture looks inside, whether you have the 3 layers, you're running the hexagonal architecture, or different types of architectures. And you're going to have different types of tests that can help you test those different types of architectures of your microservices. As a general rule, without going into specific case studies or looking case by case at individual companies and individual teams, what I've seen, this approach could work okay most of the time, right? And maybe not all of the time, but a lot of the time this could be good enough, right? And what this means is instead of a testing pyramid, which sometimes we talk about, you have a testing honeycomb where you have a few tests that test your microservice with another instance of a microservice or its dependency. You've got some integration tests that test your microservice as a black box, so fire some API tests, and then on the other side you have API or service mocks, and then you've got some tests that test the detail, which goes back to tools like, let's say, Mockito for Java or PowerMock, that would allow you to mock classes and methods in your Java application. So in this case, you'd actually use more than one tool for test doubles. On the implementation detail, in the implementation detail test, you could use Mockito or PowerMock, etc. On the integration level, you could use Mountebank, let's say open source traffic parrot if it's commercial, and integrated doesn't use any test doubles. And again, this is just one way of structuring your tests for your microservice. There's other ways, and it will depend on case-by-case basis. But the point I'm trying to make here is you might want to use more than one test. And in this case, it'd be one tool for in-process mocking, which would be Mockito, and another tool for over-the-wire mocking, which might be, let's say, Mountebank or traffic parrot. That answer your question? And again, I'm happy to go into details, right? You know, there's different architectures that make total sense in different types of context. And, you know, the architecture would look differently then, right? I'm just trying to answer the general question as best as I can. And yeah.
So maybe for me, it would also be very interesting to know, actually, I mean, what you showed now, at what point in time are we at this honeycomb? Because you actually said, well, we started somewhere with a testing strategy, and then we continue, and we should evolve our testing strategy somewhere, so that we don't end up with in the beginning that we have all these test microservices, and then we get stuck somehow and cannot scale anymore. So how does that actually evolve in your experience, and maybe with some anecdotes you have?
Yeah, totally. So from my experience, if I was it's case-by-case basis again, right? If you look at those case studies in the article, you'll see there's some very different cases, right? But that's just to make the point that there are different architectures, different situations, different team compositions, different products, etc. And that will the complexity of the whole situation will mean that there's different answers to the question. As a general rule, if I was to answer your question right now, how do you maintain your testing architecture on an optimal level for the current complexity of your product? I would do it in a similar way. You do that with your code. So what you do with your code is you write something and you start refactoring when it bothers you, right? Let's say more or less as a general rule. You can do the same on an architectural level, not just your testing architecture, but general product architecture. So you could, so what we see in typically, for example, is people actually don't start with microservices. They start with small monoliths. And that's probably the best way to start your project. Just start with a small monolith and figure out where the domain-driven design bounded contexts are for individual microservices. Once you've done a few features, right, they're going to start emerging maybe then. So what you do then is you along the way refactor this small monolith, might start splitting out some microservices, testing the monolith with real instances of microservices. Then you might start adding those test doubles, different types of test doubles, etc. But the general rule in my experience here is it's a continued effort to refactoring not just your code, not just your test, but the testing architecture and the overall architecture of your system. And then we could, you know, if we had specific, you know, projects, I'd be happy to comment on them. It's just that, you know, there's very different ends of the spectrum, right? And there's too many variables here, right? But I would, as a general rule, if it's possible, as you do your refactoring of your code, you follow the same principle with refactoring of different types of architecture, testing architecture, and your microservices or the product architecture. Does that make sense, Oli?
But this sounds a little bit like you would start with a monolith, basically always.
So I've been on projects where there's been a lot of senior people and they're very smart and they just see the bounded context because they've done it 5 times. Let's say I've been working with these guys creating credit risk for big financial institutions, and they've done it a number of times. So they just know where the bounded contexts lie, and it's very low risk that they get it wrong, right? They've done it so many times, let's say 3 or 4 times in the past. So they just start with microservices because they know how the end result looks like. And then we've had, for example, this client that is an insurtech startup from the US. And they actually don't know how those APIs and bounded contexts look like because they're the first company ever to create this type of new insurance product. So what happens then is they have to start with sorry, what was your question again? I talked too much and I forgot.
No, it's great. It's great. I just assumed it sounded like you always would start with a monolith.
Yes.
Especially probably if you don't know the domain. It sounds a little bit
exactly,
like that.
Yeah. So you can start with rigid bounded context rules if you have good certainty on what they are, right? If you don't know what they are, you need an architecture that supports fluent bounded context, right? And a typical one for that would be a small monolith, right? Because it can easily, you don't have multiple code base, or even if it's a monorepo, you don't have multiple deployments. And the contracts in a monolith are much easier to test. Let's say you're using Java. If you change one class and the API of that class, hopefully the way your build set up, the other classes that depend on it suddenly start breaking and their test break, etc. With microservices, to get that level of certainty between different microservices, it's if you're not using consumer-driven contract testing, it might be hard to get that level of certainty. Yeah, actually, let me share my screen for a second again. And try to find the blog post from our pay blog. 1 second.
I think that this is a good topic regarding where to start, and even in my perspective as well, in like 99% of cases should start with a monolith, because it's very rare to actually know the bounded context. It's only people who already have deep domain expertise to have certainty in what it is. For most people, it's actually a discovery process, and then we could go from a monolith to modular monolith, where we have multiple bounded contexts split as modules, and then translating the modular monolith onto microservices.
Perfect. Yeah. Perfect.
I totally agree on this one. Have you ever seen moving directly to microservices without cutting into modules first?
Yeah, I mean, like I said, those were the people that work on risk management systems for financial institutions. They just knew how it looked like. I was on one team. I was working with one team that was creating a product for mobile numbers in the UK. And the bounded contexts were pretty clear that just because the domain was very simple. So, you knew you're going to onboard new numbers. You knew you're going to port new numbers. You're going to onboard new users. And it was pretty like self-evident that the bounded contexts are going to follow that. So the team went straight into those individual microservices. And there were some refactorings that had to happen for technical reasons, as well as the bounded context switched a bit. Just because it wasn't just some of the technical requirements were not foreseen to start with, like those integrations with a third-party API that was behaving so strangely. You had to actually manage it with a separate microservice just to abstract away the complexity and provide a simpler API to the rest of the product. But generally, I think those were the 2 cases that I've seen that started off with microservices and didn't have problems, right? There's this recent, I think, Oli, you sent me the link earlier today about the Amazon Prime study, right? So I've seen that actually before, and that's an example of where somebody's the developers have found, as far as I understand. I haven't been on the team, so I'm just trying to interpret what they've written in those short 4 paragraphs, right? Literally short 4 paragraphs of that article. But one of the interpretations you could have for that article, and again, I don't know what happened there really, because I wasn't on the project, and it's hard to infer from just those 4 paragraphs what really happened. But one of the things that could have happened there was they actually started with microservices, and they went back to this monolith just because the bounded context of those 3 microservices, or however many they had, was actually spanning those 3 microservices to start with, right? So it just made sense that the bounded context was those 3 features or functions or whatever it was. Yeah, but I totally agree with Valentina's point here that it just makes sense to do gradual refactoring. And I like to think of this. So when we think about our tests, we think about red-green refactor. You start with something that's not working, you make it work, and then maybe you refactor, right? You can think about that on your architecture level as well. Make it have something that doesn't work, make it work, and then maybe refactor. And one of the ways is, and I like that a lot, is having those bounded contexts first appear in the monolith as modules. And then if it makes sense, if you need the advantages of a microservice, for example, one of these bits changes 10 times a week, and the rest changes once every 3 months. Just sometimes makes sense to extract this one bit to a separate microservice, so you have the separate deployability, which comes with microservices, but the rest, maybe all those modules can stay in the separate monolith that just doesn't change that often, right? But you get the power of frequent releases without the downtime or risk of impacting the other service. I just shared here this article that we've got on our blog. It kind of tries to demonstrate that there's a development cost associated with a given architecture, and it supports different product complexities, right? So let's say number of services or features. So typically microservices are going to be more expensive to start with, but there's an inflection point in complexity where they're going to be less costly than a monolith. So for example, I don't know if I'm interpreting it again, I don't know how the Amazon Prime situation looked like. They were doing this monitoring service, right, for the Amazon Prime, whatever it was. Maybe they were somewhere here, right? Maybe it just made more sense. It was less costly to run a monolith for that feature. I've worked personally on products on both sides of the spectrum, right? One of the case studies you'll see in that article that I've linked to is a case study where there was 100 or 120 microservices and developed by, I don't remember exactly, let's say 7, 8, 9 teams. And the microservice architecture was working beautifully there. You wouldn't call them necessarily microservices because they had more than one service in them sometimes. They were like micro monoliths sometimes. But there was 120 of them, not just one deployable unit.
Good. Just the last thing, it's quite interesting that you implicitly assume that we are doing something like bounded context and domain-driven design where we do microservices, because I think maybe that was also the problem, that they started with microservice because it was the new trend and never thought about how to split that stuff actually.
Let me actually, I think we might, what works. I agree with these guys a lot. Let me just find this 1 second. This was in 2015. Okay, got it. So this is a bit what I think this is what you're referring to, explained by ThoughtWorks, Ole. So ThoughtWorks has got this radar when they discuss different trends at different points in time. And what they said in November was that there's this thing called microservices envy. And teams just migrate to microservice because, we haven't got microservices. So we got to start migrating. And they specifically, already in 2015, which was what, 8 years ago, they said, microservices are great for certain conditions, right? But just keep in mind, there's additional complexity, and you got to have proper DevOps culture, etc., to make them work to your advantage rather than disadvantage. So totally with you there.
So we actually we are already quite late, so we still have some questions. Let's look at them before we run out of time. So we have here, dear Wojciech, can we think a mock test is better than stub test? I tried stub test 1 to 2 times because of my curiosity, and I didn't detect any bug or improvement. Can you give more detail in memory, please?
Yeah, totally. So what I'm hearing from you is you've tried a test double, either stub or a mock, and you weren't able to find new issues in your software because of it. So what I would question is not necessarily whether mock or stub is better for use case, and I would probably start typically with mocks, not with stubs, just because there's open source libraries for that, and they're going to restrict you in the usage so that it's easier to get started with, right? And you're going to have tutorials, etc. But what I would think about is, so the short answer is mock is probably most of the time better, right? But what I'm reading from your sentence is that, or from the problem description, is you use the test double regardless of what type, and you were not see any improvements or any new bugs found. So what I would question is, first of all, what was the problem you're trying to solve with your test doubles? And we've listed 9 or 8 problems that test doubles typically solve. And let's say you wanted to find a new bug. So that to me means, what I'm hearing is, you're not actually automating testing, because automated testing just let's say we're not talking about BDD, TDD, and those kinds of processes. We're just going to talk about simple automate regression tests. If you're automating regression tests, you're not finding any new bugs, actually, right? What you're doing is replicating manual processes as automated processes, and when the regression, when the software regresses, then the bugs will appear. But to start with, you just got an automated way of doing something that was done manually. There's no new bugs, actually, right? So if you use that for a test double in that kind of context, it might be why you haven't seen any new bugs, because you've automated a manual test, and there was just no bugs actually in the manual test to start with. But if you wanted to use this, if you wanted to, let's say you didn't detect any bugs, you'd like to find a new bug, what I would do is think about, well, how can I simulate hypothetical or error scenarios using a mock or a stub or any other type of test double, and put my system in different conditions that will raise some issues, potential issues. And let me give you an example. So I was working with this company where they were integrating with a third-party service that had around 25 or something different error messages. And the system, the microservice that was connecting to that system, had to respond in different ways to those different error messages. Unfortunately, the test environment for the third-party system, you were only able to configure only a few of those error messages. So what that means in this case is you're actually not able to test your microservice in some of these error scenarios. If you use the test double, a mock, a stub, API, or system simulator, etc., you're able to simulate those other error messages and hence find potential bugs in your microservice. I hope that answers the question.
Great. And let's look at the last one we have. What do you think about developers that don't want to involve with the testing process? Like, that's not my job, it's tester's job.
I mean, you know, there's different ends on the spectrum of how you could, address this. I'm guessing Diego is a software tester working on a team, and he's getting too many small issues he'd like to focus on complex issues and finding complex bugs rather than just simple ones. That's my guess here by interpreting what he's saying. So if I was approaching a company and talking about this type of problem, it's a consequence of how the company looks at quality, in my view, right? So the company as a whole is not looking at, well, everybody's responsible for quality. It's just QAs. They're a quality gate. And what you're saying here is might be a consequence of that, right? So you as a tester, let's say, and I'm assuming, I'm just making an assumption, you might not be a tester, so apologies if you're not. But if you're a tester working for a QA department that's separate to the development department, that's how I'm interpreting your question. What I would do is talk to your head of QA or your director of QA and try to have a conversation with them. Well, how come developers are not thinking about quality as well? And you might discover different things. You're a technical coach. Okay. Yeah, so I would just try to address it, you know, at the company level, right? Not what I'm hearing from you is you have tried it on an individual level and it hasn't worked. So and I've seen that as well. And in that case, sorry, what I'm the way I'm interpreting this question, and I've heard it before numerous times, is that you've tried talking to the developers and it hasn't worked, right? So the other alternative is talking to the director or head of QA to raise it at a different level and talk about where the big powers are and think about where does the quality happen, right? And maybe it's time for the company to think about well, actually the quality happens across the board, not just in the QA department. I need to know more about the specifics of the situation to tell you more. This is like a general answer.
Yeah, it is a good question. Maybe I'd like to add something because I may have encountered similar challenges. So the problem is, well, firstly, when people hear the word testing, they think, okay, tester testing, developer coding, and some may even see testing as an additional overhead. For example, developers who are thinking, well, we're under tight deadlines, so by coding we will spend less time compared to coding and testing. The way that I like to rephrase it is, do you want to be coding plus manually debugging? So that's like option one. And then there's option two, do you want to be coding and not manually debugging, but instead of manual debugging, replacing that manual debugging by some kind of automated testing? And then it sort of becomes, I guess, a clearer distinction. And then when we get to that realization, then the next thing that I would like to look at is, okay, quality as a whole, but let's see how we distribute responsibility for quality. So certain things like, for example, testing a microservice and aspects of testing such as unit testing, integration testing, and even component testing, which is Chris Richardson's term for the widest, I mean, testing of the microservice itself. It's essentially clear developers of who owns the microservice, and that is a responsibility of the developers. But then when we look at the, let's say, bigger picture and looking at end users and the wider system, that's when it goes beyond the scope of one team, when it goes on to multiple teams. And that's where I personally see, okay, testers as essentially being more involved. So I see it as a spectrum of quality and looking at how we distributing ownership. And yeah, it is I would say, an issue regarding silos, both due to company culture and also due to the belief that people think it's like, is it coding versus coding plus testing, but when it's actually coding and manual debugging or coding and automated testing.
Cool. So we are at the end. It was very interesting discussion. Wojciech, thank you a lot for your contribution and your presentation. And I think we could talk for hours now, but sadly we cannot. We still get some answers always. We already had that, but let's finish off. So if you want to learn how to deliver quality software faster, then just follow us on Meetup, YouTube, LinkedIn, you know it, and also join our Discord. Thanks a lot for tuning in, and stay tuned for more, and visit our next Meetup sessions as well. Thanks a lot, and see you later.
Thank you, everybody.
Have a nice evening.
Thank you.
Bye-bye.